In 1495, an invading army of 50,000 mercenaries seized the city of Naples. Within weeks, a new and terrifying disease erupted in their encampments. The symptoms were remarkably violent. Victims developed painless ulcers that quickly gave way to full-body pustules. Within months, the infection ate through bone, causing flesh to literally fall from their faces before killing them. The continent's leadership was entirely unprepared. The Holy Roman Emperor, Maximilian I, formally proclaimed that humanity had never encountered an affliction of this nature. Europe was grappling with a novel biological threat. The pathogen had found a population with exactly zero immunity, and the resulting panic swept across the continent far faster than the disease itself. Instead of mounting a coordinated medical response to the crisis, European nations immediately resorted to xenophobia, desperately trying to assign blame for the outbreak to someone else.
The Italians pointed at their invaders and called it the French disease. The French called it the Neapolitan disease. The Russians blamed Poland, and the Turks blamed the Christians. Beneath the political finger-pointing, a genuine medical debate formed. One group of physicians argued the disease had always existed in Europe but had recently mutated. The other camp proposed the Columbian hypothesis, that Christopher Columbus and his crew had carried the pathogen back from their 1493 transatlantic voyage. The relentless focus on national pride stalled the investigation. The true epidemiological origin of the outbreak was buried under layers of politics, turning the pandemic into a 5-century scientific cold case. The prime suspect was finally identified in 1905, Treponemal pallidum, a fragile, corkscrew-shaped bacterium. The bacterium has subspecies causing different diseases, like syphilis, yaws, and beetle, but they share 99.8% of their genetic code. Being nearly identical may leave the exact same erosion pattern on bones, making it impossible to distinguish the illnesses by damage alone. For centuries, researchers looked at heavily damaged skeletons sitting in European museums and declared them proof that syphilis was ravaging the continent long before Columbus set sail. Relying strictly on skeletal damage yielded entirely ambiguous results. Every diseased bone from medieval Europe was a question mark, freezing the investigation until researchers could look past the bone and read the genetic code. The stalemate finally broke a decade ago when laboratory techniques advanced enough to extract fragile bacterial DNA directly from human remains buried for millennia. In 2024, an international team successfully reconstructed 9 ancient treponemal genomes. Every single one came from the Americas, with some samples tracing back 9,000 years. This physical timeline had already been corroborated by the archaeological record. Take a close look at this 6th-century clay figurine from Mexico. You can see distinct raised lesions matching the physical markers of the disease. The definitive test came when geneticists applied this exact same DNA sequencing to the European skeletons previously used to argue the disease existed there before 1492. Every single European sample was reclassified. The DNA proved those medieval patients suffered from yaws or beetle, leaving the scientific community with exactly 0 confirmed cases of pre-contact syphilis in Europe. The genetic evidence was completely asymmetric. The pathogen's entire family tree roots deeply in the Americas, and the specific variant that triggered the 1495 epidemic traveled strictly east across the Atlantic with returning Spanish ships. When that isolated bacterium encountered a European population with no natural defenses, the results were cataclysmic. Up to 5 million people died in the first decade of the outbreak alone. The biological exchange went both ways. A single pathogen crossed east to Europe, while colonizers carried a massive wave of diseases west. The scale was lopsided. Syphilis killed millions of Europeans over centuries, while European diseases killed tens of millions of indigenous Americans in decades. Despite their own physicians documenting the timeline of the outbreak, European leaders spent the next 500 years steadfastly refusing to accept that the infection came from their newly claimed territories. The endless cycle of assigning blame to their geographic neighbors functioned as a psychological shield, allowing European empires to avoid confronting the direct, horrific consequences of their own global expansion. The pathogen that triggered that 15th century panic never actually disappeared.
Today, the World Health Organization tracks over 7 million new syphilis cases annually, and global infection rates are actively rising. The DNA resolved the pathogen's geographic origin, but one critical mystery remains open. Researchers still do not know exactly when or how the bacteria mutated from a non-venereal disease into its highly contagious sexually transmitted form. Answering that specific evolutionary question carries immediate modern stakes. Treponemal pallidum has successfully evaded every attempt at vaccine development for more than a century. Mapping the pathogen's evolutionary past provides the blueprint for finally neutralizing it. Isolating the exact moment it adapted to survive its transatlantic journey reveals the specific biological vulnerabilities required to develop the first successful vaccine.